Hello, beautiful humans of the internet, humans, robots, extraterrestrials, and fellow cyborgs. It is I, Dead Program, back again with the live stream from beautiful La Pipa in Asturias, España. I am here, of course, with GopherBot, and the two of us are wearing our masks because although we have been fully vaccinated, it is better when in interior environments to maintain your protective shields up. Stay safe out there, my friends. Very, very important. Luckily, there's no other humans here, just some clones and cyborgs, so we should be fine. So, yes, lots of exciting things happening in the worlds of technology. Let's start out with a little bit of news. Jumping to the Linux desktop. So last week, I was making some fun joke comments about the problems on the International Space Station. Yes, when the Russian module docked, the thrusters, actually 3 hours later, after the docking, when they were out of contact with the Russian Space Control Center, the thrusters went off on their own. So apparently the situation was much, much more dangerous than previously reported. Everybody thought that the International Space Station was only out of alignment about 45 degrees, 50 degrees. It turned out it was 540 degrees. So, yeah, luckily for the astronauts, the people on the ground kept their cool and got things back under control. But that could have been a very serious situation. Wow. Software. It is very important, and it must be tested. In somewhat better space news, the Ingenuity, the awesome Marge helicopter, has made its 11th flight recently. This little copter, this little drone, is just, it doesn't stop giving. It's so amazing what it can do. They thought it would maybe survive one flight, 11 flights. So I have here really cool visualization that shows the horizontal flight trajectory of this recent flight. And if I look in here, let me see if I can find this. There's actually well, I lost the image, but there was a really cool image that showed all of the different flights combined together. So Ingenuity is a long way from the rover now and is actually scouting out new territory. So that's pretty incredible. Robot space exploration, that is the way. Crewed space flight, kind of dangerous, maybe kind of expensive, not convinced. Speaking of awesome robots on the red planet, Zhurong, the fantastic Chinese rover with the awesome smile, this is a really cool visualization that is showing all of the different steps in the journey from the landing site down here. Let's see if we can increase the size. Yeah, the landing site all the way to where the rover is now. So, covering some ground on another world. Robots, that's the way. So here on Earth, on the other hand, Copernicus, which is the satellites run by the European Space Administration, and they're used for monitoring weather. Here in Europe, it's the second hottest July on record. Not here in Asturias, of course, it's very cold, but everywhere else it's really, really hot. Look at these surface air temperature anomalies. So, getting kind of serious. If you haven't thought about your carbon expenditures, you should. All right. In slightly happier news, here's some really cool stuff that I've seen this week in the world of TinyGo. So, Senior Enterprise Geek, a.k.a. Keeg Org. I don't actually know this person in real life, I don't think. But they have been doing some really cool things with TinyGo and WebAssembly. Specifically, they've been developing, apparently, during their paid time off. Paid time off? Wow, what's that? Anyway, as I was saying, during their paid time off, they took an iPad and they've done all of this development using nothing more than TinyGo, Fastify.js, and their iPad, all using WebAssembly. This is really, really cool looking. I haven't seen the source code yet, but I'm going to get a hold of it so we can check it out on here. There's a lot of amazing work going on in the world of TinyGo, WebAssembly, and WASI. So we'll talk about that more in upcoming episodes because this is really cool stuff. I'm just loving it. All right. So speaking of TinyGo, we have this really important pull request here submitted by yours truly for the search functionality and to be added to the site. And so this basically is getting merged in right now because we really need this. So let's do it. Here we go. All right. Delete the branch. So that should be deployed in just a couple of minutes. Let's see. We'll go back and we'll take a look and we'll see the new site search activated here on the TinyGo website. Hopefully that's still working. Okay. So last week, we managed to get merged in a really great pull request from Soy Pat. Soy Pat has been doing some really interesting stuff with the Raspberry Pi RP2040. It's a more formal name, chip circuit. I always call it chip. So it's basically a protocol for having chips communicate directly with each other when they're on the same circuit board. And it uses 4 wires, one for the power, one for the ground, one for sending the data back and forth, and one for the clock, right? So let's go and check to see if this pull request that's been added actually adds support. And we'll do that by testing this SSD 1306 OLED display. Let's go and take a look here and see about this pull request now. So Soy Pat has already submitted a few pull requests, and I think there has been some feedback on this already. So if we take a little look, we'll see that they added the pin definitions for the different boards. In this case, what we care about is the Pico. So the Pico is, if we look at the pin out here, it's using the, for data and clock, it's using GP4 and 5. So GP4 and 5, we can see here, is kind of on the, if the jack that we plug into is on the bottom of the board, then 4 and 5 would be on the bottom right. So let's, or we could just look at it the same way as the illustration. That's too easy, but we'll do it that way. So 4 and 5 is on the top left. And so it's pins, this actually is quite literally pins 4 and 5 from the top. Hard to beat that. So let's take and plug in this cable that I brought. And of course, these colors don't match any colors that we might. I'm not sure if this cable actually works. I have some other cables here somewhere. Oh, actually, I have an even easier way for us to test this. If I go and I rummage around in my bags of tricks, somewhere here, I can find it. I know I have one. Oh, yes, here we go. I actually have a separate display with the cables already attached. That'll make it a lot easier, right? So let's go back to... So let's pull out this little board. We'll use that later. Let's... we could probably just leave in the SPI cables. And so this is our SSD 1306 board, and we've got the cables plugged in already. Ground is black, so that would be on our pinout. That would be the third from the top. So that one there. Then we have the pin 4, which is for the clock. Pin 4 for the clock. So that's the one right below the ground. So if we go and we look at which one of these is the clock pin, and the clock is the white one. So let's plug that right below the ground. Then naturally the data pin must be the one right below that. Let's just verify that. So yes, actually we want to use... Let's go back to that data, to that code for a minute. Because that doesn't quite look the same as what I expected. 0 should be GP4 and 5. And 1 should be 2 and 3. And if we go back and look at this, we see 4 and 5, GP4 and 5. Oh, I see. That's not actually pins 4 and 5. That's GP4 and 5, which is actually on pins 6 and 7. Right, that's what that code showed us. Let's go back and look real quick just to make sure, because that will never work. So here we are. So for I2C bus 0, the data should be GP4 and the clock GP5. So GP4 is on pin 6. So the data is on 6 and the clock on 7. Okay. That's a little different. The ground is still okay. But now we want to put the data, which is this kind of brownish cable, on number 6. Which it just so happens I have the board going in the correct direction, so it's actually labeled 6. Very nice. And then 7, which would be, I believe, the white for the clock. Yes, that's right. Okay, so we're good. Now we just need the power. Let's take a look at the power. Power, we can pull that from pin 36, which is the 5th pin down on the other side of the board. So if we go take a look at that. Oh, actually, we already previously, we took the power out from that and we put it into our rail. So I can just plug this in. In fact, I can do the same thing with the ground on the other side. I can just plug the ground in on our rail here, which should be powering all of the little devices that we have plugged in. Okay, so in theory, this is plugged in and it should work, right? Let's go find out. So we take a look. We see we've got our display. We've plugged it in. So now we just need to go and pull down the actual code for this implementation, which the way that we do that is... so this actually cannot be rebased, but we can merge it, squashing it. So we'll just check out -B. That's in the main TinyGo repo. Here we go. So if we get checkout -B, whoops, it'd help if you saw that. Get checkout -B for branch, the SoyPat branch of the I2C RP24D. And so we're going to create that branch name from the dev branch. And then we're going to git pull from SoyPat's fork, of course, rebasing it. So now we've got that code. So now we should be able to, if we make this so that we build it, and we've got all of the latest TinyGo goodness, just in case I didn't do that already with some of the other changes that might be in there. So let's go over to the drivers repo here. So in the drivers repo, I have an example that lets me use the SSD 1306. Here we go. That is the same board. And this one is a, what's the size of it? It's 128 by 64. So if we go look at our main program here, so we're just using the same I2C bus, and we're using the normal pins, default pins, whatever those are. So this should just work. We'll find out. Let's see if the TinyGo rebuild is done. Yes, that's done. So we just need to copy that from our build directory into the right place for our 116.3. And so now if we go TinyGo version, we see that it is the 15ED4C2, which should be our last commit. And that is, in fact, what it is. So, yes, we got the right code. Very good. So far, so good. So now if I build and flash this by saying TinyGo flash, target, Pico, and then we're going to use the example. Wait. We want to be over in the drivers to actually flash this, because that's where the example is. Let's make sure we have the right TinyGo version there. Yep, same one, 15ED4C2, development version. Very good. All right, so now if we TinyGo flash, and our target will be the Pico, which is the name for the small Raspberry Pi board that I got from Raspberry Pi. Thank you very much. And we use the examples for the SSD 1306. And we use the example that's for the I2C interface with the 128 by 64. So that should work. Let's find out what happens. We'll try to flash it. Failed to flash. Okay. Oh, forgot to plug in the Raspberry Pi. That would help. There we go. Now it's plugged in. We know it's plugged in because we can actually see the previous program. So when we flash it, that program will stop running. So the lights will freeze. Eventually. Nope. Still can't do it. Let's see. Oh, with the Raspberry Pi, you have to hold down the button when you flash it, when you plug it in. So it's unplug it, hold down the button, plug it in, release the button, and now it's ready to be flashed. This time we'll flash it, and yes, we can see that the I2C display is in fact working, and it's drawing these little delta V lines. You know, get it? Space, it's everywhere. So, yeah, all right. Wow, great job, Soy Pat. It totally works. So let's squash and merge this, because they've been working on this for a while. So tested with my SSD 1306 display, and worked perfectly. Thanks, Soy Pat. Now merging. Well, actually now squash and merging. Something kind of went wrong with this pull request, and I don't know what happened. They have some conflicts because of some conflicting changes that they were not able to successfully resolve. But if we use squash and merge, it will turn it into a single commit that has what we need, and we can just leave it for the simple instructions of adding I2C support. Wow, that is so awesome. Thank you, Soy Pat. That is so cool. All right. Great job. We need those outside contributors, inside contributors, any side, offside, any contributor on any planet from any kind of entity. We will be grateful for your pull request. Thank you. All right. Let's take a quick look and see if there's anything else we can easily get in there. So they are working on also a pulse width modulation example, which looks like they now need to... something's not working too well with this. So I guess we'll get back to that at a future time. Cool. That is really awesome. Let's take a look and see. I have a couple of other pull requests that I wanted to take a quick look at before we start working on some other stuff that I wanted to work on today with all of you, my dear friends. So recently in the TinyGo drivers repository, long-term contributor and awesome human being Sago35 has been, as usual, cranking out incredible numbers of awesome contributions. This time, they're all about the WIO terminal. So the WIO terminal is a very cool little, it's powered by an AT-SAM D51, which is an awesome ARM Cortex M4 microcontroller from Microchip. And Seed Studio is the manufacturer of this awesome little device. And it has a built-in OLED display. It has a built-in ESP32 compatible Wi-Fi chip. Actually, no, it's not an ESP32 compatible Wi-Fi chip. That is incorrect. It is, in fact, the RTL 8720DN. RTL 8720DN, which is, of course, a Wi-Fi and Bluetooth module, but of a completely different kind. Similar, and yet completely different than the board, which is typically included on these microcontrollers. So, over the last couple of months, we've been seeing just an amazing number of contributions from Sago35 specific to adding support for this cool board that is got on it another cool board for Wi-Fi. So most recently, the most recent pull request was, in fact, I think we can just run this so you can see it. It actually added support for the TinyGo drivers repository's own version of the net HTTP library. This is needed because we have different connection requirements, and the standard HTTP library, that's part of the standard net package, it doesn't work that well when you're trying to use it with these external adapters like we are bare metal. So let's take a quick look and see this last week's pull request. Let me see if I can get that focused in. So this is actually communicating with the Wi-Fi. It connected. It's kind of hard to see. See if I can get that a little sharper. That's pretty good. So it connected to the Wi-Fi, and it used the HTTP extensions that were added by Sago35 to be able to actually go out and try to fetch the tinygo.org website. And since the request is being made without using HTTPS, it is redirecting. You can kind of see that. Can we see? Let's make it a little bit bigger. We can see that it's 301 moved permanently because Netlify will not let us access the insecure version of the site the way that it's configured. So it's just automatically redirecting, and it's showing all of this on the built-in display. Wow, that is so cool. So this week I thought we would take a look at this most recent pull request that is intended to add some examples that are also compatible with the AT-SAM D21 and other chips that use the Wi-Fi Nina, which is the ESP32. So in theory, did I bring it with me? Oh, I forgot the board. Well, I forgot the board I wanted to try this on, to try using this exact same example, but on the Pi portal. So I guess we're going to have to take a look at this pull request maybe next week when I have the right board with me. Either that or I'll just do it between now and then, because this is too good to not try out and maybe get merged. Because what does this actually mean? This means that all of our same examples that are using the Wi-Fi capabilities that are built into the TinyGo drivers repository will work regardless of which one of these Wi-Fi chips is currently in use. So it will support both the ESP32, which is so commonly used, it's in almost everything, as well as this new kid on the block, the RTL chip that's built into the Seed Studio device. So, I wanted to try that out, but I forgot the board. I pulled it out, but I didn't bring it. Darn! Oh well. Well, we'll do that next time. But this is looking pretty good, and it's actually a very small change. It's just switching over from using this TLS package to using the HTTP package, and then instead of doing all this work to create a request manually by composing together the format that's used for an HTTP request, and you can see that right here. This is an actual HTTP request in the form of text. Oh, help if we saw that. An HTTP request in the form of just plain text. Instead of doing that, it replaces that code just by calling the TinyGo HTTP package GET. So it just works the way that you would normally write your basic REST APIs in Go, except it's running in TinyGo. I really want to try this to see. I know this works on the RTL, but I want to see if this change makes it work with the Wi-Fi Nina. We'll do that next week, because this is actually quite important for extending our wireless communication range even further. Okay, so speaking of wireless, well, actually, before we do that, let's go see if this change to the TinyGo website actually worked. Yes, site search. So let's look for the WIO terminal that we were just looking at. Here it is. I click on that. And here is the documentation page. So wow, that's really cool. Site search thanks to Algolia. Very nice. Thank you very much. It's actually working. All right, so we can close that. So, last week, I was hanging out with friend Lorenzo, and speaking of wireless communication, and we were working a little bit on trying to create a better version of the TinyGo Tiny Flight Controller. So if you've seen any of the talks that I've done recently, you may have seen that we have added support for Bluetooth in the TinyGo Bluetooth package. And there's a separate package called TinyGo Mini Drone, which is a wrapper around the Parrot, Mambo, and all the other Parrot mini drones. And so this little flight controller, which I can show you my version of it. It's here somewhere. Ah, there we go. So I brought this cool little, get out of here, WIO terminal. We don't need you. We don't need you anymore. So this is my homebrew version of a very small flight controller. And the only problem is it's not very stable with all these breadboard cables. Some of them want to pop out at any given point in time. So talking with chum Lorenzo, we thought, hey, let's build a slightly better controller. So I think he's here, and he may have brought some of his gear. We'll put on our masks just so we can set good examples, even though everyone here has been vaccinated twice, at least.
Hello, mate.
Hey, what's happening? How you doing?
I'm
It would be much better to have, a slightly larger controller. And so I thought that this larger board that you had brought would be good. And then I realized after that, actually, we're going to need to make more than one of these.
Okay.
Here's why. Because what I want to do is I want to be able to add, not right now, but add soon, I want to add an ESP32 along with the Bluetooth. That way we can also use this to fly different kinds of drones, ones that have built-in Wi-Fi. So I thought before we go too far with the chip itself, maybe we should just look at what we're going to do about the controller part for the joysticks. So I brought some of these connectors we were talking about last time, ones that were not bent. Oh, that's better, thank you. A little bit better light. And so I know it's 5 pins over. So unfortunately it's going to destroy the other pins.
You're going to sacrifice one.
Yeah, I'm going to sacrifice for the greater good. No, this thing is
Okay.
this is a good chopper. This was well worth what I paid for this tool. It's quite good. I've been chopping at things all day. It's great. Okay, so here's the other one. Eventually we'll sand off the edge maybe, but for now it's certainly good enough. Oh, shit. Oh, oosh, oosh.
How many?
Oh no, wait.
Maybe
It's still okay.
can survive.
It's barely, but it's just okay. All right. So what I was practicing before was bending over these pins in a better way. And I figured out that if I do it like this, I actually can bend them pretty nicely. Let me... So that we can... That's a little better. That way, what you were saying last time, I recall, was if we put these through, we can wire wrap from the other side. So it's 5 pins, so let's see. Let's say 5, let's say it's the second 10th. And this way, you were saying that it would be pretty good because there'd be lots to wire wrap it to. So if we just did a little spot solder job,
Yeah, one can be.
it makes it easier for us to wire wrap them to whatever we want to attach them to. Do you still think that's a good idea?
I think we can try. I mean, wire wrapping is.
Well, we should solder it in. That way it doesn't come loose.
Just one.
Well, we could solder them all in because that's way it holds steady
Okay.
when we plug in. Make sure it still works. The joysticks, and that way there'll be a joystick on either side. So I brought my little programmable soldering iron. I can't just use a normal soldering iron. That would be too boring. So instead, I have this pine sill. I don't know. Did you see this?
Yes, it looks amazing.
So this is really cool. It's from Pine 64. Very cool open source hardware company. And so I just received this just a couple of weeks back. And in order to actually, we have to unloosen these screws. I have a screwdriver. We have to loosen these screws to actually put in the tip. Because it actually holds in pretty well. So let's unscrew. And then put in this and tighten it back down. It's so small. You can run it off battery, but that's not, I haven't really tried that yet.
How long does it last?
I think not very long. I mean, it's got a lot of amps. How long can it possibly last? And then let's see, where's my, here we go. But so instead I brought this 12-volt power supply because that definitely is going to give it juice. We just need to plug that in to something. And of course I have a nice slim cable. I think that it will fit. I think it will fit into this power strip we have right here in the front.
Okay.
I don't know if we have enough amps, but I think it will fit. There we go. So then plug in my German-made power supply. At least that's what it claims. It's a German company name. I don't know if it's actually German. Probably Chinese. Plug it in, and you see it actually, on its little OLED display, it's telling us that we are plugged in. And so we might need to bring up the wiki page to remember how to use this, which is really funny. Let me unplug it, because I also have to look for my... I'm not sure if I brought the apparatus to put it onto. We don't want to start any fires. Let's see if I brought the... I have a cool little stand. I may not have brought the stand, so we might have to use something else. Look at the size here of the holder for my big normal soldering iron. I don't know if that's going to even work. It'll be good enough. I don't think this is going to heat up that much. So let's bring up the wiki page, because I actually can barely remember how to operate this device. So the PineSill wiki has instructions on how to control the soldering iron. It's the first soldering iron I ever needed to actually read the documentation for. I know, it's kind of embarrassing, but what can you do? So it says to, let's see, here's the tips, where's the control, let's see, oh, here we go. All right, so clicking the plus button starts the tip heating. The display then shows power draw, current temperature, supply voltage, and estimated time to reach your desired temperature. Wow, that is like really fancy. If you put it down, the accelerometer that's built in detects that and will reduce the heat. Wow, okay. This is more professional of a soldering iron than I am at soldering. Clearly, since right now I can't even figure out where the end of the solder is. Let's see here. Oh, here we go. No, that's the other end.
That's the beginning.
The beginning, the end. You know, what's the difference? Has to be here. Oh, here we go. It's very skinny, which is okay because we don't need that much. So, let's see. Plug in the soldering iron. It boots up. It's heating up, you can see. There's the temperature. It's heating up a lot very quickly. I don't know what it's set to as the target. 315. You think that's hot enough?
For this one, I guess. So I usually 350.
350? Okay, 350.
But it's
350. Okay, 350 it is. It's heating up. Let's see what happens. When the smoke starts coming out, you'll know the reason why. So we should be able to just... Oh yeah, I definitely smell it now.
maybe for
Oh yeah, look at that.
for SMD maybe it's too much, but for the connectors should be fine.
It looks like it's hotter. It says it's 370. I think we better turn it down a little. Let's turn it down to, let's say, 325. Okay. See if it's still hot. Oh yeah, it looks pretty hot. Seems hot to me. So the main thing is I want to get it pretty snug so that you have as much room to do the wire wrap as possible. So let's see here. Don't do this at home, kids. Okay, I gotta say, this is a good soldering iron. It's really nice. Oh, maybe a little too much solder on that one. I may need to take some of that off. Okay, so let's see if it actually turns the temperature down when you put it down. Put it down and...
Stand by. It takes a while, maybe.
I don't think it's working. Maybe I don't have that mode turned on. I was looking for the solder sucker here. I put a little too much. Got a little too enthusiastic with the solder. I was so excited about the ability to do the soldering with this little guy. Or thing. It has no gender. It's simply a tool. Yeah, I got a little too much. It's not that hot, though. That I can tell.
If you want me to...
No, it's better to... Soldering is like surgery. One person should hold the knife and the other stand back. Obviously, I've never performed a surgery.
But if someone holds the...
You know, it's heating up again. I think it was better with the hotter temperature. It seemed like it was a lot better. Let's just put it to 340.
40, yeah, I will hold it for you.
Well, no, I think it's better if we put it down.
Okay.
That way I don't accidentally burn you and then you're like, oh, that really hurts. And then I feel really bad. Yeah, that's definitely better though, I can tell with the all right. Yeah, we can put a lot less solder. I didn't realize there was so much solder on the tip when I started. Oh, that's a lot better. I can actually see now. That explains everything. This tip is not the sharpest tip. And yeah, I think it'd be a lot better if it was hotter. Let's put it back to 360 now. Can't see that one on that side because of the glare. Oh, there we go. Pull a little more off there. All right, that's a little better. Now I can actually see. All right. Just a little bridge between these, though, just because I got a little too messy. Probably needed a rag or something.
Let's clean the tip.
Yeah, let's clean the tip. And we can prove here, from looking at this, it does not lower the temperature when you put it down. It for sure is not.
In my it takes
I would not touch it if I were you.
It takes a while.
No, I just think it's not doing it. Luckily, I have a. Be better to wet this.
I'll go with. Don't worry.
Yeah, but we could probably just wipe it off.
Nice.
It's not the best, but it'll do. Okay, that's better. Yeah. It seems like it's not hot enough.
Probably
you can see from the solder is not too...
It lost the flux, so it's better probably if we remove everything and
just clean it? Yeah, I'm sure you're right. So let's do that. Because it may not even be in there that well. Actually, it is.
No.
Here, let's do this. Let's get the tool.
No, Hold on a second. What are you doing?
I'm not cutting it. I'm just want to hold it with something.
Ah, okay.
I don't have anything to hold it with while I let it peel off. I mean, these pins are not that good. They're very cheap. And now they're stuck.
But can I have a go? Let me see.
Of course.
Now we need a magnifying glass.
Yeah, neither one of us can actually see, can we?
Oh my God.
And a much brighter light.
Do you have a multimeter? Probably we can see if...
Well, now that it's all mangled, see how it's kind of bent, I think the best thing to do, I'm going to put this down.
Okay.
That way we don't burn ourselves. And now that I've destroyed it, I think we can just cut them out. We could just get another board. We'll clean this board later.
We use the other side if you...
No, yeah, we'll do that later. But I want to have one that at least looks good. So here's a 5. I have some more boards.
Okay, I should have it in here.
No, I brought more boards. I brought all the boards I got from you.
It's the same, no?
This is this really small. Oh yeah, those are the same. Yeah, of course.
I'm not sure if it's the same, but what is the other?
I think it's... Oh, maybe it's a little smaller.
Yeah, I think it's...
It is a little smaller.
Do you want to go with that, or you prefer it?
Well, I wanted to use this bigger one for the... for when we attach the Wi-Fi chip. So we can use... Unless you think you can just pull them out. But I don't have another crimper or tool.
I have these. Let's see, one by one. And we will...
I have some helping hands somewhere with clips, but I didn't bring them.
Okay, let's do...
Oh yeah, we need that. We need that water so we can actually clean the soldering device.
2. Come on.
Okay, the sponge is now damp.
3.
Doctor,
And
I'm not even a good nurse here.
okay, and this one. And 4.
Okay.
So now we will... I think we can reuse these ones.
Yes, now we can actually use the solder sucker the way it's meant to be used to clean the board.
Oops. But it's not hitting
It's
very
not.
well.
Yes, I know. That's what I was saying. I'm wondering if we need to turn it up more. Because I mean, it does claim that it's at 360 degrees, but
It's quite a lot, eh?
it should be plenty.
Yeah, I think that now we I don't know.
Now we're destroying the board.
There is one.
It's not a very good board. I mean, that's just
Yeah,
how
yeah.
none of these boards are.
Okay. Well, I think we can see through, so I guess we can try the next.
Oh, that's plenty good enough.
I think so.
We could try again.
We
All right.
Should we?
Because we wanted to do it on the other side. So this is. Should we try to stick it in and then bend it, or?
Yeah.
It's-
Okay.
Probably need to clean a little bit more off.
I know, but if you have this one is better for bending it if it fits. Clean a bit more.
It doesn't quite
Fits.
slip through.
Yep, probably we have
A couple of them are partly closed. Oh, I got it.
Perfect.
Just a little extra emphasis. Because we do want to, but we need to bend it before we solder it.
Yeah, it's much better. You have this one which fits, so.
Yeah. Oh yeah, that's actually way better. Of course, we need to do it the other direction, so it sticks out so we can plug it in. 510. Okay, there we go. This is more like circuit bending than it is, you know,
Mind bending.
design. Mind bending, yeah, exactly. It's mind bending. Okay. Yeah, this looks better.
You see, it went to sleep mode. Zzz. It's just about time.
Oh, it did do it.
Yeah,
It's just
yeah.
waited a while. Oh, I see. That way, if you put it down for a minute,
It does not switch
it
off.
doesn't switch off until it thinks that you're done. There's probably a setting in there somewhere to control that. Are these clean enough for you, or should they?
Whoa. We should measure it if we have a multimeter before.
Oh, just to make sure that there's no shorts.
It looks clean to me, but my vision is.
It looks clean. I'm sure it'll be fun. What could go wrong? Drone crash.
Yeah. Or maybe-
All right. So, do you want to solder this one since I mangled the other one so badly?
Okay, I can have a go.
Might want to let it heat up a bit first.
Yeah.
Which it should do automatically. Oh, wow. That was quick. It's pretty cool. I can remove some of the items we're not using so we don't burn those up. Did it work?
Looks like, but the problem is I'm blind. I usually use the magnifying. Do you have the magnifying glass? No.
I do not have that with me. That would have been a good thing to bring. I should have done that. I'll cut the other connector. Oh, too far. Ah! Jeez. I'm mangling these connectors faster than they can make them right now, which is amazing considering how fast they make them. Because these are the ones with the long pins, and those are a little bit... I only got those with the boards that... Oh, wait, here's one. Okay, this time I have to do it right because we're running out of materials.
I mean, yeah, what do you think? I mean, I didn't put enough, but we connect with the wire wrap so just to hold it. At the end, we don't mind about the connectivity.
Yes, that's true, and really it's just to make sure it doesn't fall out when I'm trying to, you know, massage. When I'm trying to mangle the drone controller. So this time, 6. Let's just get a little bit closer. So I can cut off this other pin. Okay, now I got 5. I don't want to have too much hanging on there, but okay, that looks pretty good. So now we'll put it on the other side, same as what we just did, which was 5 down from the top, which is E. Yes, confirmed, E. And then bent over by holding the pins this way and just sort of bending them. And then trying to bend them back a little bit so that they're not quite so out of alignment. Yeah, what do you think?
Looks good, look.
You know, went to sleep. It's got a little Z message on there. Oh, that is so cool. See, we're going to have to program that with something before we're done. Not today, I'm saying, but before we're done with this device, we're going to have to put some custom, you know, display message on there. On the wiki, it's got instructions on how to do that. Well, not a custom message, but how to recompile it. Okay. Are you ready, Doctor?
Okay.
The patient is not alive. Luckily, the patient did not start out alive, so nothing's changed as far as that's concerned. Cleaning the tip between each solder joint. Very nice, like a true professional.
Heating up the copper, and then let's see if that works.
I mean, I know it's a little gimmicky to use the pine sill as opposed to the other soldering iron, but
I
it's
love
just,
it.
but it's so
It's
cool.
the first time I'm using it, and it's like having a pen in your hands, and it's
Exactly. The cable is the worst part. I need a slightly better cable.
nature. I think it's okay.
Yeah, exactly. Since we're going to do the wrap, and we can experiment right now just by plugging in the joysticks and see how it feels. This one's a little off alignment.
Ouch.
Not much, just a little. But I mean, you could just, the way you plug it in, it's still fine. Hey, that feels pretty good. What do you think?
And if you add more weight to that, it looks like good fun. Yeah, well.
I mean, probably. So now that I look at this, I realize in the future edition, we should probably mount these a little further over so that we can put
Yeah, you're right.
something to sustain the weight, even though.
With some hot glue in here, and it will become a lot more.
Exactly. So the next edition, luckily we can reuse the same parts.
But anyway, we wanted to maximize the space, so.
Okay, so this so far so good. So now we should look at the buttons. Did you bring those buttons with the LEDs?
I forgot it.
Well, okay. Let's look at the.
I knew.
Then let's look at the display instead.
I knew there was something.
So I brought. I do have a 4 connector that I did cut correctly before. Which.
Are you going to do within the board, or with the? We have to flip the screen. I don't know if the driver allows to.
The driver does allow us to flip 180 degrees. So that was what you were suggesting last time. You thought...
We save space maybe on the board.
Yes, we do. That is true. And also it gives it a little different angle of inclination. You were suggesting... Oops. Basically to make it a little easier for us to see just by having a slightly different angle, which is just the same exact thing, just bending it a little differently. Since, I mean, this has to be disassembled for transport, but that's easy to do right now.
Yeah, everything, so...
Okay, that seems like a good plan so far. So let's see. So this is 36 pins minus 32, 16 on each side. So 16 on this side and 16 on this side. It looks a little off only because there's an extra edge on here. And let's just put it on to make sure that that's true. Yeah, that looks right. Okay, so we said we were going to bend it back the other way a little bit, not too much. Wait, I did it the wrong way.
Well, but you can turn it.
Luckily, yes. Because we wanted to have it.
No,
This
no,
is
you were right. You were right. Absolutely right.
Okay.
Yeah, it should go in, and it will.
Yeah, that way it's angled towards us slightly.
Correct.
Even though that's going to be hard to solder that in, probably, at that angle.
No.
The other one, it's flat. That's not. It's a little flat.
Oh, if you leave it like that, then we have. Let me have a look.
Yeah.
Okay, see, if it goes like that, then we have this kind of inclination, the 45 degrees angle, which makes it ergonomic.
As long as it's even across this way, otherwise it's tilted a little.
But we can bend it later, maybe a little bit. There is some room for it, I guess.
If
no?
needed. Yeah, okay.
Let's do,
That sounds good.
I will probably.
That sounds good.
So I think by his way. We can.
Yes, exactly. We could take off the pieces to
And I will solder.
use the sponge as our guide as well.
Let's see how it goes. Oops. Okay, it's in temperature.
It heats up pretty quick.
Let's see if it's not too. But I think we have some room for.
Change as needed.
Looks.
Oh, that looks pretty solid. I mean, that's like very pro. Customized controllers. This one we may have to bend it over a little more, just because it's. You can see it's got a little.
Yeah, it goes.
But you could probably just bend it. Like, I don't know if you can.
Let me have a
actually.
look. This one is more tight than this one. For example, I can.
Maybe if you push it in instead of pulling it.
But I don't want to break it. Well.
Yeah, I think you're right. Let's just not mess with it. We learned something about getting it aligned anyway. So this is pretty good. So we could actually test this right now. The way we could test it is I have the cables.
Would you like? Yeah, you are right. We can, but we can also.
Let's see if I have a male on one end of the.
Would you like to try with wire wrap or?
Ooh. Well, I just wanted to see if the display was still working.
We can have color.
Or if we killed it yet. I could just use these jumpers. Let's see.
Okay, I know what you mean. Yes.
I have if I have like I think it's what's the output? Where's the pins of the display? I guess I just need we could even use the Raspberry Pi we just used, actually, if we wanted to, right? Because we need
you need maybe.
I don't even need to flash anything. I just need the right.
I have quite some cables.
Oh, you've got plenty of DuPont cables. Yes, yes, you do.
It's
I just need male and female. Exactly. So let's just use.
I don't know if
these four.
Okay.
They seem likely. And so if we plug in the same, I guess we'll make the power
Brown, the red one.
Red and brown. Unplug those. And then let's make the data. I forget which one is which. Actually,
I usually the SDA, like the orange one. It's the no, this is SPI. Yeah, the SDA.
I don't remember which order
orange.
they're in, but I can look at this and see that the brown one here is. The brown one is data. So it's data and then clock.
Hold on, you were saying that brown was the negative.
And on this
brown.
right here.
Okay, sorry.
So data is this brown. So it's data and clock. So if we make, like, say, the data yellow.
Okay, so SDA, it's then the brown. Sorry, the orange.
Data.
Data is SDA.
Oh, it's not slipping in there. Wow. pen. Oh, there we go. Okay. So,
So
power.
here we have the leftmost is ground.
Leftmost is ground.
On the rightmost, well, probably you want to.
Power.
Rightmost is power plus.
Then we said data.
Sorry. Higher.
And then the clock will be this one, I guess. Okay. So now if we just plug it in, we should see something on the display.
Ooh, careful with that.
Let's find out.
Beautiful. Oh,
Oh,
so good.
we're missing out on the... Yes.
No, you cannot see. Sorry, I will.
And then it is kind of hard to see.
Yeah, now you.
But at least it is working. Okay, we didn't destroy anything yet. This is excellent. This is excellent. We're off to a fine start. Okay, let's see. What else can we do? We tested that. So I don't know how we want to connect them yet, but that's the next thing we could look at is what do we want to do about the chip. Because for that we said we were going to use some, let me find it here. We said we would use some sockets, so we have to solder both the pins onto this board and then the headers onto this if we want to be able to plug it in like we said on the bottom like this. That way we actually still have room for the Wi-Fi chip if we want, and we still have room for the buttons. But you were saying originally you thought we should put it up here.
Or down, just to access the USB thing, maybe.
I mean, we don't have anything over here. And this way we still have room for, because we're going to need room for the ESP32 chip if we end up putting it on this board later.
Do you have one here?
Because
I have one, but it's you know, the all-in-one with display, etc. We don't want that.
I have one.
Is this one we were using? No, it's not this one.
I have an ESP8266, but that's not the same exact pinout. And
Something.
that's another. But the main thing is just to leave enough room, not to put it on now. And if we think that this is going to leave enough space,
Yeah, we will solder just one here. I mean, on this one, on the breadboard.
because what I thought we were going to do, maybe not, but is that, whoops, ripped the bags out of their shell, but not the bag itself. Does that mean it's a really good bag or really bad? I don't know. Whichever.
Bad bag.
Let's see. I don't think I have I might have the exact size already broken off in here. Let's see. No, they're a little short, but that's okay.
This is,
Yeah, it's too
you have to break.
It's too short.
This is short. Maybe with this one you can get two. Oh no, they are same.
Whoops. Got one extra. Well. So what we were saying we would do was that we would put headers on so that we could take it on and off. But then you said that made it a lot harder for us to be able to use the wire wrap.
In that case, we cannot use the wire wrap, but then it's just a point of soldering. So it depends how you would like to do it.
I see. You're saying it won't be hard to remove if we really want to.
In this case, if we just solder one pin, it will be very easy.
Like on each side.
Yeah.
I mean, the top pins we have to solder, but the bottom pin.
Yeah, the bottom just one.
Okay. I'm willing to try it. Because trying things is what this is all about, right?
Having fun, yes, I agree.
Waiting for new parts as we hopefully don't destroy the existing parts. Okay. So the main thing is to make sure we put it going the right direction. All right. So now we should be able to solder this. As long as
I
it's-
would put it on the breadboard, maybe. Or if you have a breadboard, it will be the ideal place.
I do. That is a good place. You're absolutely right. I have one. Maybe. I heard one a minute ago. Here we go.
Okay, perfect. So let's see.
I just need to take off this other chip. MPU 6040. I just have like a lot of these around. It doesn't have to be in there it doesn't have to like be set in there. It just needs to be sitting there, right? Basically.
I don't know this format if it's because I saw that they were going like that, converging too much.
That's
for
true.
my taste.
Yeah, I would agree.
Maybe that's not the right.
Holes, yeah, I have in the wrong.
How does it?
There we go. Yeah,
Ah, it looks good. Yes, yes.
yeah, I just didn't have it in there quite correctly. I think that's going to be the easiest. 'Cause that way we don't have to
Yeah, it looks
push
perfect.
it all the way in.
It fits.
All right, where's the solder?
Wake up.
Wake up, little soldering iron.
I will.
Work to do. Yeah, that's actually pretty nice.
We need a fan to remove the magic smoke.
Yeah, it's not good to breathe this. I swear I didn't inhale. You know, after living in big cities for so many years, if this is the worst thing I inhale, I'm probably okay. Probably should have looked to make it. It's aligned. It's like, up too late. It better be aligned. If not, well, we've already
Too late.
soldered it all in.
Yeah.
So let's get the other side. This is a really cool little soldering iron. I'm totally amazed at how cool this is. Okay, almost there. Just a couple more. This solder doesn't have lead in it. That's why it's not that good. Lead solder, that's the best solder. I mean, it's the worst solder, but it's also the best solder. I had the last bit of my supply of vintage 80s Radio Shack, and I'm pretty sure that it's all gone now. Alright, so take a look, see what you think. Oh,
Careful.
yeah.
But I think it.
We can even look at the micro view. We can focus it. You can see if it looks good to you out there in our studio audience. Looking pretty shiny. Okay. Cool. All right. So now let's go back to what you were just saying, which is if we just tack it in one place, just one, and we should go, how far over from do we want to be?
Maybe one more and.
One more this way?
Yes, close to the.
Like so?
Although it's not strictly necessary. If you think there is a lot more mesh within the board, we can. But probably it's better to leave some room.
Yeah, no, I think that's a good plan. Let's take off the display. And let's
We
take off.
usually solder only the ground pin.
Yes, that's a very good idea. which is the second. So it's pin B27. Hit! B27. Oh, whoops. Oh, I see. It doesn't quite fit. If we do it like this, though, we'll be fine. Okay, you want to do the honors, or shall I?
Well, I don't know which one is...
B27.
B27.
I see it. I see it. I think I can get it.
Yeah.
If I could get all of the, whatever it is, all of the alien infection. I guess we're the alien infection in this case. So B, second row, 27. That would be this pin. So I'm wait till it gets hot enough. Then go in there. Okay, I think that's it. If I lift it up and it doesn't fall off, it worked. Hey! Okay. All right. We have now succeeded, apparently, in attaching the one pin. So I guess if we want to prove that this at least is mostly working right now, we could wire wrap the I2C pins only, flash this with something, and then see the display work, and we've proven that part of it, right?
Good idea.
Okay, do we actually need the soldering iron at this point?
No, anymore.
Or should we turn it off? I think we don't need it right now for the next few bits. So let's actually unplug it. It's still going to be really hot, so we have to wait a bit for it to cool off. So I'm going to, this is okay. I'm going to put it over here to cool off a bit. Cooling off period for the soldering iron.
So shall we go with, I will prepare some cable, 4 cables here. Okay?
Yes.
Let's see, I remove this one because I think they are a bit broken.
We can move this out of the way because we're not going to use this anymore. We're actually going right for the real display. Oh, this is so cool.
It's the same colors.
Hopefully we're not going to need this. I can put that away. And then we keep moving a few of these extra cables out of here, because we don't need any extra mess.
Let's see how it goes.
It's kind of like, you know, when you're a chef and you clean up as you go. Yeah, right. You've never seen me cook. There's stuff everywhere in the kitchen. No, I'm not that bad. Nor am I that good.
So, what is the display? This is one, right?
Yes.
So let's say ground.
So it's going to be sorry.
This is positive, right? The second one from the left.
That is correct.
Okay. So it's 7. Well, 7. I go by heart. I don't mind. Let's see what comes up. Too much, but it looks.
Oh, cool.
It looks beautiful. Yeah, I know.
Yeah, that's very solid. Also.
I usually cut like that long. Maybe that one was too much. You have to insert it in my...
It's kind of like a needle and thread.
Yeah, exactly. But
You just have to stick it through the eye of the needle, more or less.
yeah, it's difficult because my hands are shaking.
You know, that's why we don't perform real surgery on real, like, anything.
Exactly. On poor robots.
I know, they don't complain much. They're saving it for the right time.
Let's see. Would you like to try one?
And so, same deal that we said that the ground is the furthest. Okay, yes,
Yeah.
that looks good.
So without making a lot of pressure, we just leave with the weight of the tool, and it should
Just neatly
come up
curl
quite
around. Oh, that's really cool.
neat.
That's very neat. Like literally neat, both in the sense of very cool and also very clean.
Then we use what was the orange? It was the data, no? Well,
Sure.
it doesn't matter.
It doesn't really matter
ju-
now,
ju-
but
just
let's just say, yeah.
to stay consistent. It will be easier later on.
Yes. Okay. That seems like a good plan.
Okay.
Also, it goes all the way through on the outside. So it
Yeah,
is very
that-
much
that-
like a needle.
It is. And that was the data. It was the outmost on the right.
Yes, that is the furthest one. That's
I
correct.
should have leave it like that. And now the yellow, well,
The yellow will be the clock.
clock. Okay, I'll hold it, bend it a bit, and
You just turn it until it uses up all of the amount that you put through, basically.
yeah, it doesn't really matter, but I mean, you see it's kind of consistent and it's a good connection. Now we have to be careful not to, I usually then measure properly, but this time we did it like,
So I guess the question now, though, is what do we do about the ground? Because on this board, we only have the one ground pin.
One thing I do is I do one binary. I will short circuit one, for example.
One rail,
one
basically?
rail, yes, yeah. In this one, for example, I was soldering. I removed this
Oh, so you use a piece of wire and you just
and
solder it at each of the little taps?
do something like that, so that the ground you don't have to mess anything there.
Instead of just laying the bead of solder.
Yeah,
That's probably smarter because
we
that
can do
way...
it into a.
Well, so it's the second pin here, which is the one we soldered before, remember? So if we just put a little run over...
Yeah, you can use this one, for example, and you can make a rail.
Or I could use one of these broken pins from before. 'Cause
This one is. I think
This is
it's,
better?
It's cleaner, in my opinion. That's
Okay.
too.
that seems good. I like it.
We
Because
can,
it's the one that's... What we're saying is we're going to basically
and
short
then-
a few of them in this
sorry,
direction, right? Whoops.
Yeah, you can use that same rail.
Like this. Not that far, but like maybe
Maybe an L.
4 pins. That should be probably enough.
Yeah.
Or maybe even all the way to 22.
Do we have another ground? I think
Not on that board.
Not on that board. Okay.
That
that's
board
fine,
only
that's
has
fine.
one ground pin.
Okay.
That's the reason why we're doing this. Because if it had a second ground pin, we would just use that. But since it doesn't, it just seems like that's going to be the... Which was the piece that... Oh, this was the piece. This was just as an example.
Yeah, we can.
That's... Because if you look,
We can do an L here as well if you.
See, in the past, what I've usually done is just lay solder beads across.
But that's fine. I mean.
But the thing is, this seems like it might be better because it's less likely...
And you just solder one end, the other end, and then all the rest comes easy.
Because you don't even need... But how do you wrap to that then?
No, you don't wrap it in here. Well, you can, but
How do you... Well, the question is, how do you attach the ground, this wire, to that?
Well, depend. Okay, this one we can go straight onto it. We can wire wrap some other stuff on top of this one, for example. Depends how many grounds. I told you, I was mixing wire wrapping with some soldering as well.
Just because
I have
what
to-
it makes me think, just from... is what we could do, because we want to be able to wire wrap on this side of the board. So what we could do is we could just put in... This is too far. We need one that's only like 4. Let's see if I have the short one. Here we go. This is perfect. What we could do is, since we want these to be able to wire wrap to, and we want to connect to this, we could... Now we have the pins to connect to,
But you have to go from.
here to here. Right? So if-
Do not. No, I think this will complicate things a little bit. If we just go a small rail, solder it, and then you forget about. I mean,
more than this,
the-
for
the-
example. How about this?
okay, even that would do.
Because this is the ground, but you're not going to touch that normally. And if you need the ground on the top
Yeah,
of the board for some reason,
That will be nice.
then
yeah.
this way we can just. But they're not connected to each other, so we still have to do the bead of solder all the way along. But this way it's easier because it's
Yeah,
got
I mean,
the pins to attach to.
The idea of the rail with the ground is just because everything is going there,
Well, we have
but everything else.
1, 2, 3, and then the ones for the buttons. So we have at least 4,
Yeah.
right? And we have here those 4 pins plus the original one. So we could, it seems like that, but maybe better to have 5 since we're doing this. I mean, is this a bad idea or is this a good idea?
No, I think it's a good idea. Better to have.
Just because we're not going to fabricate anything specific. This is just, we're only going to work with, you know. Wait, we did it. How do we do this? On this side or the other
Is it
side?
6 or?
Or do we do it on the other side? We did it on this side. There is one more hole. If we think that, because you always need another ground. Right now we have 6 pins. We have the original pin,
Well, remember
and then these 5.
we can pick one here, wire wrap it onto the same.
It's
And
like
then-
it's just this way you have a good ground on both sides. So, and then we just have to lay across.
One thing we can do is, I don't know, but maybe this one can go like that. This one wire wrap to here, and you're done.
Mm-hmm.
We can, I mean, if you can put this one, let's do one thing. Let's wire wrap the ground to this one, and then we do this binary you were.
Instead of
the
doing
rail-
it here, do it
Yeah.
somewhere else that's less.
Yeah, with the
in the way.
in line with the ground. What do you think?
It's hard to complain about that because it makes it more out of the way.
Computer